Cache memory is introduced between the main memory and processor to speed up the operations, right? The processor is very fast, whereas the main memory is slow. So to bridge the speed gap, cache is introduced, but the size of cache is very small when compared to the primary memory. Hence, blocks of data from the main memory should be mapped to the cache. This mechanism is called mapping technique, and we have three mechanisms: direct mapping, associative mapping, and set associative mapping. In today's video, we will be learning how associative mapping is done. Before we go into the mechanism, we have to analyze the disadvantage of the direct mapping. Already I have posted a video which will explain you clearly the process of direct mapping. I am going to take the same example and I am going to just analyze what are the drawbacks of the direct mapping. So in this, though the cache was not full, when the CPU requested for this block, we had a cache miss. So block 0 has to be replaced with block 4, though there was empty cache lines. So in spite of having empty cache lines, we had to transfer the data back to the main memory, and the new block was shifted to the cache memory, or the new block was mapped to the cache memory. So this is one of the disadvantage of your direct mapping mechanism. This led to the associative mapping mechanism. Associative mapping mechanism has a flexibility where any main memory block could occupy any location of the cache. It could be placed anywhere inside the cache. There is no rule on where it has to be placed. So here, this main memory block could be placed in any position of the cache. This is one advantage of your associative mapping. So let us take this example. The same structure I have taken. Main memory is 128 bytes, cache is 32 bytes. So you require 4 bits for your block index and 2 bits for your cache index. So now I am placing block 2 in the cache. It could be placed anywhere inside the cache, so I am placing it in the line 0. Yes. So what will happen is the tag bits are the bits which will contain the value of the block index. So directly all the 4 bits 0010 of the block is copied to the tag bits. So it means that whichever block is there in the cache line, the corresponding block index will be placed in the cache. So here the size of the tag bit has been increased. So this tag bit holds the index bits, block index bits. So here this cache is now full. It contains elements and its respective tag bits are also filled. Now if the CPU is giving a physical address, let us decode how it happens. The physical address contains two components. One will be your block offset and the other is your tag bit, which is nothing but your byte, which is your index, which is your block index. Okay, so we are going to check 0001 with the tag bits. Since we don't know in which line the block is present, we have to compare the tag bits of your physical address with each and every tag bit. So this tag bit of the physical address is compared with each and every tag bit corresponding to the cache line. So number of comparators is also increased. Though it has a flexibility of it can store wherever it wants, it can map wherever it wants. Here the number of tag bits has increased and also the comparator circuits have increased. So we are going to compare this tag bit in the physical address with the tag bits of your that is placed related to the cache lines. Okay, so if there is a match, then it is said to be a cache hit. So here we have got a match from the third line of the cache. So once we have found out the line, this byte offset, okay, this byte offset will be used to find the corresponding word. Okay, this byte offset is used to find the corresponding word in the corresponding cache line, and that word is transferred to the CPU for working. This is how your associative memory works. If there is a miss, in this example you have the tag bits as 0, 0, 1, 1. In this case it is compared with all the tag bits and there is no match which says that it is a catch miss. In this case we have to go check whether the catch is empty. If there is no space in the catch, then you could use the catch replacement algorithms, first in first out, most recently used, least recently used, or random algorithm, in order to shift the block back to the main memory and shift the new block to the catch, so that we will have a catch hit. This is how associative mapping works, and you have to understand the components of your physical address. The physical address has n bits, where the least significant bits will be your byte offset, which will be used for identifying the words, and the most significant bit will be your tag bit, which is nothing but your byte, which is nothing but your block index. Hope you have understood how associative mapping works.